I'm an undergrad at Mississippi State University majoring in animal and dairy science, hoping to go to vet school. I work alongside Dr. Graham Rosser, and I'm here to present the morphological and molecular characterization of Dejardinascus waltoni and the American alligator and its larval form that's found in the spotted gar in the southeastern U.S. Just a quick overview, I wanted to go over how the American alligator and the spotted gar both play their roles in their native ecosystems. I wanted to go over Dejardinascus waltoni, the parasite found in this study, and its morphological and molecular characterization, and then end it with some feature work and acknowledgments. So the American alligator, it's a keystone species and apex predator, keeping other species in balance. We call it an environmental engineer because they create these things that are called gator holes, which are shallow bodies of water that are used as breeding pools for fish, crustaceans, and amphibians. This picture right here was taken in Alligator Alley. It is a yearling that hatched earlier in 2023. Alligator Alley is an alligator sanctuary, a very nice place in Floribama. Definitely recommend the trip. This alligator in this picture right here was a 10-foot alligator found in the Noxubee Wildlife Refuge in Starkville, Mississippi. It was very calm when approached. You can tell that a lot of people probably walk near it, and she's just really used to people being near her. This alligator right here was found on Google Images by me and Dr. Rosser. The spotted gar is the main predator of crustaceans in low oxygenated water. Gar consumes small fish, algae, and insect larvae, and they are a main food source of the American alligator. They're called a trash fish due to the fact that they eat pretty much everything that they can find in the water, which is why all these factors make both the American alligator and spotted gar ideal hosts in the life cycle of parasites. Some of them are shared between both hosts. And for this alligator project, started by Ethan Woodyard, it was to survey the endoparasites found from alligators in Mississippi. We received these alligators due to Mississippi's alligator hunting season, which is a lottery-based system where, say, 100 people would apply to get their alligator hunting permit, and only around 5 to 6 win it per year. After killing the alligator, they send it to a processor. In this case, it is Mr. and Mrs. Kane who graciously donated the GI tracts of these alligators. Mostly the people that bring it to these processors just want the head, the claws, the meat, which is mostly found in the tail and the neck, and they leave the couple 100 pounds of GI to whoever wants it. And the survey of parasites from spotted gar being discarded after the fecundancy studies at Nicole State University, that is where we found our larval stages of waltoni. In this video, we can see the Dejardinascus waltoni when it's still alive. We use very hot water to relax them and prepare them to have DNA extractions. In this picture here, you can see Ethan Woodyard cutting into the GI tract of an American alligator just to extract parasites and see whatever he can find in the stomach contents. This right here would be the trunk of the alligator. It's a couple 100 pounds. It's a very physically intensive project. And to prove that, here you can see the alligator which this GI tract was taken from, and the fact that it has to be toted by a tractor should say a lot. Nematode recovery. All of these nematodes right here were found in one 10-foot long alligator. This is what it looks like after all of the parasites have been picked up from the stomach lining found here. And they get into the stomach lining using their external papillae to basically shaft themselves in the epithelial lining of the alligator's stomach and sometimes the top of the small intestines. So what we know so far, the Dejardinascus waltoni's definitive host is the American alligator, and its site of infection is the stomach and sometimes the small intestine. It leaves ulcerative lesions associated with attachment. It does not cause death in adult alligators. We don't think it causes death in baby alligators. It mostly probably causes discomfort and maybe some stomach pain. It's differentiated from Dejardinascus helicina in American crocodiles by the morphology of the gubernaculum, the length of the spicules in males, and by the morphology of the vulva in the females. The entire life cycle is currently unknown. So far we have its definitive hosts and its host before so, which is the gar, and we're trying to find out if the gar is infected by crawfish or copepods. So for the female, The morphological characterization is the length of the female would be around 25,000 micrometers to 30,000. This picture right here shows us its excretory pore, which is a very hard thing to find because if you have your worm on the slide incorrectly, the excretory pore is not visible. It's extremely hard to locate. But in this picture, you can also see that it has multiple sets of lips used for finding food, mates, and getting into the epithelial lining of the stomach. Here we can see the length of the trachea, and it usually ends to be around right here. In D, it shows us the vulva of the female, which usually is around 8,000 micrometers from the anterior side of our worm. As for the male, it usually runs around 1/5 the size of the female. Here is a picture of its gubernaculum. It's a very unique shape with a very unique name, and these pictures here show us its external papillae, which also help get into the epithelial lining of the alligator's stomach, find mates, food, etc. For our molecular characterization, we used Oxford nanopore technology in Illumina via Plasmidsaurus. It's a great company. We completed the mitogenome in nuclear ribosomal regions. Mitogenome was annotated with mitos2 and Aragorn. The ribosomal regions were extracted using ITSX. As for our blast end results, we compared the larval forms of Waltoni that we got from Nicole's fecundancy study and put it into GenBank. We received confirmation that it was 99.94% accurate to the adult form of Waltoni. That sounds great until you see everything else, Balis ascaris, and all the others. There's 98%, 98%, 98%, and so we need to go a little bit further. Here, we paired it to Gigantea with 4,190 BP of 28S rDNA. And that is a lot of DNA, but GenBank only shows 735 BP. So we matched it and got about an 83% matching rate, which isn't fantastic, so we're going to go a little bit further. And we used COX-1 this time. We used 893 BP of COX-1 and compared that to 384 of the length that was currently in this website, and got around an 88% match, which is a lot better than the previous one. The Jardinascus waltoni doesn't have a lot of research based on it, so when we go to things such as the phylogenetic tree, we can see, like right here, you want for your parasite to branch kind of like right here, how these two do. And the closest thing that we would like for it to match to, or we would expect it to match to, would probably be Gigantea. But due to the lack of research for Waltoni, we're kind of paving the road ourselves, trying to find all the molecular research we can and piece it together to see what its closest relatives really are. As for future work, we wanted to do a histopathology on the alligator's stomach, morphological and molecular data on larval stages found from other intermediate hosts. We're assuming it is either going to be crawfish or copepods, and characterize other nematodes found in the American alligator. We figured out the GAR part of the life cycle, but we still have lots of work to do, namely just finding what happens before the GAR. Acknowledgements. Thank you so much to Nicole State University for the GAR subjects. Thank you very much to Mr. and Mrs. Kane for donating the GI tracts of the alligators, and thank you very much to Ethan Woodyard and James Valentine for starting off the alligator project. Funding comes from the Mississippi State University College of Veterinary Medicine, MSU College of Forest Resources, and the Crocodile Specialist Group. Any questions?